Okay, it's recording. Hello. Uh, I just decided that I have to make the video for the introduction to codeVisionAvr software and C programming, so that we don't have to do it in the class. It's much better to watch it uh, in the video, and you can pause it and you can try everything as you go. So when you are coming to the school, there we can just do the practical projects. We don't have to spend any time on the C programming parts. So I will make few videos about this, and I don't know where I will put it. Maybe YouTube, maybe in the Moodle somehow. But you will have access to it, and all of them you will see. For today, I decided to start with these tasks, 8 tasks that I wanna make. I wanna explain today how to set up the circuit with the Atmega 8. Let's get to that, and after that, one by one, we will go through all of those. I have an example program here. I have the setup, how to connect the programmer to Atmega 8, because it's a bit different. In the other program, when we were using Atmega 32, our board is designed for it. So all of the pins, when you just put the microcontroller on the board, everything is connected. You don't need to put any extra wires for the programming. But when you're using, we want to program the Atmega 8. The other was Atmega 32. Atmega 8, it is a small chip. It will not be fitting here, and the pins layout is totally different than Atmega 32. For example, the reset pin for the Atmega 8 is this one, PC6 reset on top left side. But for the Atmega 32, it's this 9th pin. And this 9th pin basically is connected through internal wires through this pin. When we are connecting the the socket, it connects to the computer through the cable. These pins. These pins that you see 10 of them, they are the same pins. 3 of them is this SCK, MISO, MOSI. The other one is reset, and the rest of them are VCC and the ground. There's 4 grounds here, or even more, 5 grounds maybe there's in this. So we will have this kind of layout that we have to connect this programming wires. There's 6 wires. Those are programming wires. VCC, ground that we have to connect. This will be put on the breadboard, our chip Atmega 8 on the breadboard, and you will connect those wires to the breadboard from this. So this PB567 will be connected to the PB3, 4, and 5 basically. As the picture shows, I note that now you have learned how to connect the different schemes, schematic circuits and everything. But only tricky one is that pin, the reset pin, this pin 1 that needs to be connected to the 9th hole on this green body. You should count the 9th pin and put the pin here, so that we have a connection or reset from the programmer through this cable and then through here. This is all about the 6 wires that you will connect. The next thing that we have to do is this push buttons. One push button we need to connect to the pin 0. The other push button we need to connect to the pin B1. And our LED need to go to the PC5, this upper right pin. Port C, pin 5, number 5. It starts from 0. So This is the 6th pin of the port C. Then you have to connect the LED and the resistor. The resistor value can be like less than 1K, like about 500 ohms or 330 ohms, even 220 would be okay. So this one you will connect. You might ask, what is this resistor? What is capacitors for? 100 to 470 nanofarad. The value should be. Their application is that when we are pressing the buttons, there is a bouncing effect. It's mechanical, that and the push button doesn't straight connect at once to the wires. It bounces up and down a few times. During the time limit of like 5 milliseconds, it bounces up and down. So we have to use a capacitor that absorbs those this is called the debouncing capacitor. It absorbs those waves that are created during the bouncing. So one capacitor here, the other capacitor here. We have S1 and S2. These are push button 1 and push button 2. So this is the pull up, both the pull up. As you can see, these are connected through the push buttons. These pins, pin B1 and pin B0, are connected to the ground. So when you are pressing the push button, the value of the pin B0 and 1 becomes 0 because they are connected to the 0 value of the logical value of 0. 1 is 5 volt, 0 is 0 volt or ground. What else we have to say? So when we are not pressing the push button, we want this pin's value to be 5 volt or logical 1. That's why we need to do a pull up through a 10 kilo resistor to connect them to the 5 volt to VCC. But you see that you don't have to do here because we are using the internal pull up ability of the microcontrollers. AVR microcontrollers have the ability to do every pin has a resistor beside it that connects it to the VCC, but you need to activate this for every pin separately. You need to activate it in the software. In software, you should tell you want it to be pull out and pull up, or you want it to be in the tri-state. This we will do pull up in the software. So later you will see how you make the one pin to be pull up. So that's why we don't have any pull up resistor here. If there was if we didn't have internal pull up, we had to connect this from here actually. From here to the VCC, this wire here, through a resistor. Here should be a resistor and then connects to here. But we don't need it. So, yeah, this is all that we needed to know about the board. It's very important to connect everything correctly so that we can do the program. This is one of the most important parts, that we can have the correct connection and we can, anytime we want, very easily connect or download our program from computer to the to microcontroller and test it right away. So let's leave from here and go to the next one. Okay, now we see the CodeVision window, codeVisionAvr programming environment. As you can see, I have a program here that is already here. This is just with the purpose of showing you what is the most important part, what sections we need for our program to work. In the beginning, you can have some explanation as a comment. Like if you put like this, this is, what's that? No. Okay, this is the comment. Let's put it here. If you put a slash slash, then from here you can add your name, the company name, all the details, when it's done, whatever that you think is necessary for, or you can explain what does this code do in general. After this is done, you can, in this part, you have to add the libraries that you want to use in this code. For example, we have a library here that mega8.h. This is the name of the library that is explaining what our microchip is at Mega 8 chip. Its specific specifications of that Mega 8 is written in the this library, and our program will use that library. We are not gonna explain our microchip to the program. We just add this library here, and then we don't need to do anything with it. Or there's a lot of other libraries also. For example, if you want to use the delay function in your code, as I have used delay.millisecond, then you have to add another library that is basically delay library. Delay.h is the name of that library. And if you add it, then you can use this milliseconds. For example, let me there's this tool that up here, there's a tool that you can make a line comment, or for example, right now I made this line comment, so we don't have the delay library added. The CPU doesn't read this. This is as a comment. So I'm going to make the project with by clicking this build all, and it's gonna give me error. An error, this is what popped out. You can see two errors, and here you can see the delay in milliseconds. It's not recognizing here. So I say okay, and here I delete this comment signs, and now I make the project again, build all. Then this window pops up on my laptop, not this screen, so I bring it here. For you, it should. Now it says one error there is here. Let's see what is the error. This is good. You learn what the errors happen. Undefined symbol of maximum is here. So yeah, this is a function that I want to make later. So let's make this also a comment for now. I make this comment, later I can add it to the code. This is not necessary for blinking. Project, build all, and this time there's just warnings here, but no error. No error, 3 warnings, and the warnings say to me that I have variables that defined, declared, but never used. We are gonna use them later. So that's not problem for me. So here was the libraries that we add as many libraries that we need to have in our to make our program. Here we have to declare our variables. For example, int. This is the format how to declare a variable in this in the C programming. You say the data type. The data types we have studied: integer, long, char, unsigned integer, and so on. So we will have data type, the variable name. You can put whatever you want here. and then you put here the value. Here I declared I as an integer and give a value of 0 to it. We can define the variables differently also. We can define multiple variables of same type. M1, M2, for example, unsigned integer, I declare them. So this you will learn about it during the projects more. Then here we can add our function. For example, this maximum was a function that I had defined. Let's add it here because I have the code here next to me. The maximum I will add to here. So how to define a function is that you should just give the output type integer, the name of the function. Now I put maximum, and it requires 2 integer variables as an input. And then what does it do inside the function? It will define a local variable of max. If the x is smaller than the y, it will give max equals to y. So and then returns max. The max is a value local variable, so we are using just to store the maximum value and returning it to the whoever called it. As you remember, there was here a max that I commented out. Now let's bring it back. And now I have defined the function here. So if I build the project, it will not give me error. I built the project. Let's see what it gives us. You see, no error, no warnings. Why? Because inside this function, I have used the before it gave me a warning that I have not used the I, M, and these are defined but not used. But actually here I used all of them. I equals a max of M1 and M2, and M1 and M2 right now don't have a value. I can give them value later. Right now this is like empty, it doesn't do anything. I is equal to nothing and nothing, basically 0 and max of 0 and 0, which here it will give me I. All of them are basically 0. So let's go to the next part of the code. What is it? Sorry. Then we have to go to, here you define the function. You can define as many as you want, the functions that you want. Later we learn why when we define the functions at all. Then we go to our main program. Main program is this main function. This is main function. In the C you need to have the main function, otherwise your code will not work. And so far all of this was declaration and definition of the function. Main function is the code that the CPU will start executing line by line. If there is not this loop here, for example, while 1, this will go through all of this in literally millisecond, not microsecond. Yeah, every like 5 microseconds would be enough for the code to finish. There's 5 lines. It will read them, finish. But we don't want our code to finish in microsecond and then turn off. We want to have some code that continues forever. In microcontrollers, we usually have this. So we need to have a while loop. While 1, 1 means the logic value of true. So it says while true, and if we have put a 1 here, it means 1 is always true. So it means always do this piece of code and do a loop here. So when we power up our microcontroller, it starts reading from top, all of these lines it reads, and then comes here, and then starts read this, reaches here. Because the while loop is, this is always true, it makes cycle here forever. And then let's see what are the other parts. In the main loop, we have added some piece of code here that you can see. You can write all the codes that need to be executed only once in this part before the while loop. All the configuration codes will be here. Configuration means the pins of the like the microcontroller. We can decide if they are input, if they are output, what is the value that they will have, initial values. All of those we can determine in this part. And how do we determine? There's 3 main commands for it. You have like the data direction register. Here you should give the value to it. Normally they are all 0. If unless you turn them on here to give them value here, for example. So data direction register is this one. You give DDR C5, it means pin C.5 to be output. 1 means output. Then DDR B0 equals 0 means pin B0 to be input, and pin B1 also to be input. And we want the pin B0 and pin B1 to be pulled up. When you press the push button, they are connecting to the 0. So otherwise, they need to be logic value of 1, or they should be connected to the 5 volts. And this is the command to activate that internal pull-up register. So here I add internal. Later I will give the code to you also, so you can download in the model. So this code, this piece of code says I want the internal register to be activated, internal pull-up to be activated. So when these pins are not connected to anywhere else from outside with the push button or anything else, their value will be 1 in our program, unless they connect to somewhere. Okay. After this configuration is done here, this is all the configuration that we need for blinking the LED. Then we are coming here. We tell that first we want the pin C.5 to be turned on, the output, the LED to turn on. So we give a value, high value to it. High, 1, like true, all of them are the same. Then we tell delay millisecond. Delay is a function that takes in as an input 1 integer, and the integer means the number of the milliseconds that it has to make delay. How it works is that when it's reaching to here, this calls the function. So here the program pointer goes out of this or code to the library of the delay, which is here in the left side. You can see on the headers, this is the libraries that we are using in our program. It goes inside here, does the code, counts the pulses until the 1000 millisecond is passed, then comes back here, and then here we have told to turn off the port C. So it will turn off the LED light, then do the delay for 1000 millisecond again. And here we have told that the I variable equals max of the M1 and M2. This is a function that we have written ourselves here, up there, this one. And this is the function that we just wrote. It takes on two inputs, x and y integer values, and gives the input back. So here I have called that I am saying variable I equals max of m1 and m2. I'm giving m1 and m2 as an input to the max function, and the maximum of those will come and be stored in the I value. Let's give some values to the m1 and m2. For that, you can do it here, for example. Or you could do it here also. But let's do it here right now. So m1 is 2, m2 is 3. And if I run the code, here I will be maximum of 2 and 3, which is 3. So I will be equal 3 also, and the code will run forever here. But it's useless. So right now I am making this a comment. And these two also, let them be here. They are not. So this is the structure of our code. That is how it's written. This is generally how this is the minimums that codeVision AVR microcontroller needs in order to create the hex file for it. And that's it. This part. Let's see what else. What is the next part? Okay, now let's continue the second part. For example, I want to add the push buttons. Let's see how we write, for example, if clause, if a piece of function with the, for example, if like push button is pressed, do this. If it's not pressed, do that. So let me introduce you to this piece of code, the continue. If we are inside the while loop, for example, and we add this continue will be like it go to the next cycle. It means ignore this cycle, the code that is after this inside the while loop, and go to the next cycle. So this is all that continue does. If you write here break, which you shouldn't, the program break will tell finish the cycle and get out of while loop. But continue will tell finish this cycle and go to the beginning of the cycle again and start a new cycle. So we don't write break here, otherwise the program will come out of this while loop, and after this while loop there is nothing, and the program will finish, and basically it will shut down. We have to reset the program, and every time you reset it will come see the break and get out, so the program will not work long. So let's delete the break. I commented out here, so you will know what it is. This is commented out, but the continue will say that ignore the rest of this codes that are inside this while loop and go to the beginning of the loop again. So let this be here. The continue is very useful code. It can be used in future projects. And then let me add a new code to our main. So that is, let's explain what is this code. If else. I'm just putting them here together. So basically it can be here. Yeah. Here we have the code that we say if, this is the other command, the register that this pin B is used for reading inside the, reading what is inside the port B0, pin B0. We have port B0. With this pin B0, we have to read what is the value. Is it a 0 volt or 5 volt? Is it low or high? And we say if the value of the pin B0 equals 0, it means the push button is pressed, it is connected to the ground. Then turn on the port C, pin 5, which is turning on the LED light. This I equals I plus 1 doesn't mean anything, just I wanted to mention that if you are using this kind of format, you can use this sign so that you have multiple line of the codes for like if this condition is true, do multiple line of code, but if not, do another set of multiple line of codes. So this is just that. So this let's ignore for now, it doesn't do anything. Here we are telling if pin B equals pin B dot 0 is equals 0, it means it's pressed. Port C dot 5 should be on. The LED should be on. If not, else, if it's not pressed, port C, the pin should be off. And you saw how we can make, let's create a project and see if we have any kind of errors. And no, there's a warning, I guess. Yeah, I was declared and not used again. Yeah, there's one warning, but we know we are not doing anything special with this code. So that's the elementary code that we needed. But I'm gonna close this C program. This is when you didn't use the codeVisionAvr. I just wanted you to see what are the basic parts that are needed. When we use the wizard, it will make all of the required parts ready there, plus a lot of extra information that we will gradually learn what they mean. So right now I'm just closing this code, and I will go to the next video to explain how to start a new program and use do our tasks. Basically, we have 6 tasks. I will write the code for solving all of them one by one, and there you can learn more about it. Thanks. Bye.